Here we have 5 objects and we want to choose 3 objects at a time, and we want to know how many permutations and how many combinations are there. So here are the 5 objects, A, B, C, D, E, and we want to choose 3 at a time. Then we would get arrangements like ABC, BAC, CAB, and so on. And so there are a total of 60 permutations. And here, if the order is important, the order of the letters, like the order of the letters is important, then these arrangements right here will be counted as distinct arrangements. And so there are a total of 60 permutations. But if the order is not important, then meaning all arrangements with the letters C, D, and E will be counted as the same. And if these arrangements right here, if they counted as the same, then this will be considered one combination. And these would be considered one combination, one combination, one combination. And so there'll be a total of 10 combinations if the order of the letters is not important. So if the order of the letters is not important, then we have these 10 combinations right here. But if the order is important, then we have 60 permutations. And these are the 60 permutations. And this is how we calculate the 60 permutations and the 10 combinations. We have 5 objects to choose from, and we're choosing 3 at a time. And so we do 5 factorial, then 5 factorial is 5 times 4 times 3 times 1, which is 120. And 3 factorial is 3 times 2 times 1, which is 6. And then we do n minus k, which is 5 minus 3, which is 2, and then 2 factorial, which is 2 times 1. And therefore the number of permutations will be n factorial dividing by n minus k factorial. So it'll be 120 dividing by 2, which is 60. And that's how we got the 60 permutations. And then for the number of combinations where the order of arrangements is not important, then this is how we calculate the number of combinations. Again, n factorial, or the number of objects to choose from, is 5 factorial, which is 120. And then we're choosing 3 objects at a time. And so 3 factorial is 6. And then n minus k factorial, 5 minus 3 is 2, and then 2 factorial is 2. And the formula for to calculate the number of combinations is n factorial dividing by k factorial dividing by n minus k factorial. So in this case it'd be 120 dividing by 6 and then dividing by 2, and we get 10. And so that's how we come up with the 10 combinations. And we compare the 2 formulas. For the permutations, we don't divide by the k factorial, but for the combination, we also divide by the k factorial. So that's the difference. And the reason in combination we're dividing by the k factorial is this, because these 6 permutations right here, arrangements, if the order is not important, they consider one combination. And if these 6 are considered one, where the order is not important, then they consider just one combination. And so that's why we're dividing by k factorial, which is 6. You're dividing by 6 because these 6 arrangements will be counted as one combination. Now let's look at another example. Here we have 10 objects and we are choosing 5 at a time. And if we're choosing 5 at a time, then we get 30,240 permutations if the order is important, if the order of the letters is important. So here are the 10 objects, and we're choosing 5 letters at a time. There will be 30,240 permutations. And once again, if the order of the letters is important, then the arrangement A, B, C, D and B, A, C, D, E will be counted as 2 arrangements, 2 different arrangements. But if the order is not important, then all this group right here will be counted as one combination of the letters A, B, C, D, E. But the 30,200 permutations, they are as follows. And so that's 30,240 permutations. And once again, if the order is not important, then we have the number of combinations. Then there will be 252 combinations if we have 10 objects and we're choosing 5 at a time. And here are the 252 combinations. And now let's look at how we calculate the number of permutations and combinations. We have 10 objects and we're choosing 5 at a time. And so 10 factorial is 3,622,800. And then 5 factorial is 120. And 10 minus 5 factorial is also 120. And so the number of permutations will be n factorial dividing by n minus k factorial, which comes out to be 30,240. And then the number of combinations is similar. It'd be n factorial dividing by k factorial dividing by n minus k factorial. And that comes out to be 252 combinations. And as an example of the application of permutation and combinations, let's calculate the probability of getting a royal flush. We know that in poker, we choose 5 cards from a deck of 52 cards. And notice that in poker, the order of the 5 cards is not important. So we have 52 cards and we're choosing 5 at a time. And the order is not important. Since the order is not important, then the process of choosing 5 cards out of 52 cards will be a combination problem. And so it will be 52 cards, choosing 5 at a time, and then how many combinations are there? Once again, the order of the 5 cards is not important, therefore it's this combination. And the formula is n factorial dividing by r factorial dividing by n minus r factorial. So we have 52 factorial dividing by the 5 cards, which is 5 factorial, and then 52 minus 5 factorial. And then normally a scientific calculator probably wouldn't be able to handle a number this big. And so find a calculator or a program that can calculate this quantity right here, then it will come out to be 2,598,960. And so from the deck of 50 cards, and if we're choosing 5 cards at a time, then there are 2,598,960 combinations. And then now we want the probability of getting a royal flush. And then notice that there are only 4 royal flushes. We can get the royal flush from if we get the 5 cards like 10 of hearts all the way up to ace of hearts. So that's 1 royal flush, or 10 of diamonds all the way up to ace of diamonds, 10 of clubs up to ace of clubs, and then 10 of spades up to ace of spades. So there are 4 royal flushes. So out of the 2,598,960 poker hands, there are 4 royal flushes. And therefore the probability of getting a royal flush would be 4 divided by 2,598,960, which is 0.00000153. And that's the reason why in a game of poker, the royal flush is the highest hand, because it has the lowest probability. So this is an application problem of using permutations and combinations.